All right, so the way this is going to work is you're going to pause the tape when it's time to pause, fill out each part as I go over it, and then when you're done, you'll go into Canvas and complete the assignment. So at this point, your tape should be paused. You should be filling out the warm-up. When you're done with the warm-up, hit play. Here we go. A triangle has side lengths of 8, 15, and blank. Which of the following statements could be true? A says the third side could be 2, and it would be a scalene triangle, which means we'd have sides of 8, 15, and 2. Well, 15 would be the largest. 8 plus 2 is only 10, so that could not be a triangle. Answer choice B says the third side could be 15, and it would be an isosceles triangle. So that means we'd have 8, 15, and 15. Well, 15 is the largest. 8 plus 15 is 23, so yes, that's a triangle, and because we have 2 that are the same, it would be a scalene triangle. Number 2 says a group of 5 friends is going out to dinner. The friends ordered a total of $48.50 worth of food. The friends also left a 22% tip. If the friends shared the bill evenly, how much would each friend pay? So I'm going to go over this one a little bit differently to make sure you're really paying attention here. So first things first, they spent 22% of $48.50. That will give you the tip when you put that in your calculator. Now to find what the price is of the meal and the tip, it's going to be $48.50 plus whatever that tip is. However, that is not going to be the final answer, because once you add those up and get the total, you'll have to divide it by 5 because 5 friends are splitting it. Or you can put this in your Desmos calculator. You'd hit the fraction button, 48.50 plus whatever the tip is on the top, divided by 5 on the bottom. Number 3, a playground has a length of 120 feet and a width of 80 feet. The new playground is shrunk using a scale of 0.25. So it starts at 120 by 80. It shrunk, which means it's getting smaller. It's getting smaller by 0.25. So that becomes 20 and that becomes 30. The new area of the playground area is length times width. So on your calculator, you'll have to go 20 times 30, and that will give you the new area. Number 4 says determine the mean. Mean is when you add them up and divide by how many there are. The best strategy for this is to first put all of the positives together. So 3 plus 6 is 9, plus 20, that's 29. The negatives is 21, so 29 minus 21, or negative 21 plus 29, it's the same thing. You have 8 positives left over, and then all you're going to do is divide by 1, 2, 3, 4, 5, 6. So 8 over 6 is a perfectly acceptable answer. If you simplified it, it would be 4 over 3, which is also a perfectly acceptable answer. Okay, the activator. On your own, pause the tape and fill this out on the sheet. You're going to put the fraction or decimal for each of these spins. Okay, at this point you should have it set up. When we're looking for a red, well, there are 1, 2, 3 reds. There are a total of 6. So you have a 3 out of 6 chance of spinning red. If you put that in your calculator, it gives you 0.50, which is also 50%. The second one says the probability of not white. Well, there's 1, 2, 3, 4, 5 of them that are not white out of a total of 6. It's not asking for how many are white. It wants to know how many are not white. And then you go to your calculator, 5 divided by 6 gives you 0.83 repeating, which is about 83%. The last one says a probability of blue or red. Well, there's 1, 2, 3, 4, also 5 that are blue or red out of a total of 6, which is 0.83. So simple probability. It's the probability of whatever you're looking for. Maybe it's a probability of red over the total number of outcomes, which is the total number of things that could happen. All right, a real quick review. Simple probability with words. So there are 5 problems on your sheet. Go ahead and pause it now and work them out. All right, the key for this is using strategies. So in the word mathematics, what is the probability of choosing the letter M? First, I want to think about, okay, I want the probability of an M. So let me find out. Wow, there are 2 M's in that word. To see what the outcomes or sample space or the total, the denominator is, I have to count everything. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 2 out of 11. I would then put 2 over 11 in my Desmos to see if it simplifies. It does not. But as a decimal, it's 0.18, which is about 18%. Number 2 says, what's the probability a jack will be randomly chosen from a deck of cards? Hopefully you paid attention yesterday and know that in a deck of cards, there are spades, hearts, diamonds, and clubs. And so there's 1 jack in each of those. So that's 4 jacks. There's 52 total cards in a deck of cards. That's 100% something you're going to have to know. You can put this in your calculator into Desmos, 4 over 52, and it will simplify to 1 out of 13. 1 divided by 13, that probability of pulling a jack as a decimal is about 7%. Number 3, in a classroom there are 25 students. This is just a reading problem. 10 are girls. What is the probability of a boy being called on? Well, think about it. If there's 25 total students, 10 of them are girls, we want the probability of a boy being chosen. So it's not 10 over 25 because 10 are girls. So if you have 10 girls and 25 total, that means 15 of them have to be boys. Again, to simplify this, 15 over 25 in Desmos gives you 3 over 5, which is 60% or 0.60. Number 4, probability a student will flip a coin and have it land on heads. That's a simple one. The probability of a heads, coins, either have heads or tails. There's 1 heads, 2 total options. That's 0.50 or 50%. The last one, when we're talking about a dice, the biggest thing is you have to take the time. And when you turn your paper in today, we will be looking for this. You have to take the time to use a strategy, which means draw it out. We're looking for the probability of a number that is less than 5. When you think about this, there are 4 numbers less than 5 out of 6, which is 2 out of 3, which is 0.66 repeating, or about 66%. When you think about these probabilities here and where they would fall on that number line, well, 18% less than 50, that is unlikely. 7% pulling a jack, a 1 out of 13 chance, 7%, that's very unlikely. That means if you did this 100 times, you would expect to get a jack only 7 times. That's not very often. Calling on a boy in this scenario simplifies to 3/5, 60%. That is likely to occur, which means more often than not, you would land on a boy. Number 4, flipping a coin, it's equally likely. It's 50-50. That means if you flipped a coin 100 times, you'd expect 50 heads and 50 tails. If you flipped it 300 times, you'd expect 150 heads, 150 tails. And the last one, probability of less than a 5 is 4 out of 6, 66%. That's likely. And think about it. If you roll a dice, you have 4 chances to get a number less than a 5. If you need any of these notes for your sheet, go ahead and pause the tape, go back to where you need to go before we move on. Okay, this needs to go into your notebook. So take your notebook out. At this point, I should see everybody in class getting their notebook out. Pause the tape, take that top note, and then when we go through these examples, take the bottom notes. For all probabilities, when you total the outcome, it has to equal 100%. If there's a 30% chance of rain, there's a 70% chance it's not going to rain. If you have a 10% chance of winning a game, there's a 90% chance you lose the game. So if we're finding the probability of pulling one of these letters out, the probability of an M is 3 out of 6. The probability of an A is 2 out of 6. The probability of a G is 1 out of 6. Altogether, it is a 6 out of 6 or 100% or 1.00. These 3 things have to add up to 100%. That is how probability works. No matter what, there's 100% something is going to occur. And here's where we're going to look at the last couple examples here. We're going to do 2 examples together. You're going to try 2, and that's going to be it. So a jar contains 20 marbles that are green, red, and blue. So right away I'm thinking, okay, there's 20 marbles. They're green, red, and blue. There's a 50% chance of pulling a green marble. So on my Desmos calculator, I go, okay, 50% of 20 because there's 20 marbles. That means there are 10 marbles in there that are green. There are 4 red marbles in the jar. It already tells me that. So red is 4. How many of the marbles are blue? Well, there was a total of 20. We knew 10 of them were red. We knew 10 of them were green. 4 of them are red. That means 6 left that are blue. So my chances of pulling a blue would be 6 out of 20. And if you simplified that, it would be 3 out of 10 or a 30% chance. Second example, there are 100 different jelly beans in a bag. 40% of the jelly beans are cherries, so we would do 40% of 100. Tells us there are 40 that are cherry. 1/4 of the jelly beans are orange. 1/4 of the 100, so we'd go 1/4 times 100, and we find 25 of them are orange. And it says the rest of the jelly beans are grape. What is the probability of choosing a grape? Well, there's 100 altogether. Minus these 65 leaves us with 35 that are grape out of 100 total, which is 35% chance it occurs. If you needed to simplify that, you would simply type the fraction bar. You'd go 35 over 100 and see that it simplifies to 7 over 20. 35. 25 and 40 add up to 100. Up here, 6, 4, 10 add up to 20. The percentages will add up to 100. Last 2 examples. Pause the tape and do these now. All right, first one, 25% of 48 are green. So using your calculator, you would find that 0.25 of 48 gives you 12 green marbles. 1 out of 12 are red. Okay, interesting. 1 out of 6 are yellow. The rest are blue. How many are blue? Well, we know 1 out of 12 are red. When I'm thinking about how to do this, 1 out of 12, how would I figure that out? Well, a couple things I can do. The easiest thing to do is go 1/12 times 48. When I do 1/12 times 48, it tells me 4 red marbles. 1 out of 6 are yellow. If I do 1/6 times 48, that gives me 8 yellows. And then it says the rest are blue. How many are blue? Well, these 3 together give me 24. 48 minus 24 give me 24 marbles that are blue, which means I would have a 24 out of 48 or a 50% chance of pulling a blue marble. The last one, 3 friends are in the middle of the game. There's a 20% chance Mike will win. There's a 3/6 chance Sean will win. What's the probability that RJ will win? Well, I go to my Desmos calculator. I see 3 divided by 6, that's 0.5, aka 50%. So Sean's got a 50% chance. Mike's got a 30% chance. Somebody has to win the game. So there's a 100% chance someone wins. So 20 and 50, that is a 70% chance between Mike and Sean, leaving 30% chance for RJ. So then I just go to my Desmos calculator and divide these out. That's 0.7, aka 70. That's 0.6, aka 60. That's 0.2, aka 20. That's 0.3, aka 30%. If there's anything on this tape that you need to pause and go back to, do that now. In Canvas is the assignment. Use the Desmos calculator. A lot of the answers are simplified. So if you get an answer and you don't see it there, it probably means it needs to be simplified using the calculator. It doesn't mean you're wrong. You just need to simplify it. Draw pictures, diagrams, whatever you need to help you, and make sure you read carefully.